Welcome back to the deep dive. If you've been following the conversation around electric vehicles, you've probably heard the big fear. I mean, it is everywhere. It's what people call the grid anxiety myth.
It is. It's this very compelling, almost cinematic worry that if we all switch to electric cars, the second everyone gets home and plugs in, boom, the entire national grid just buckles,
Yeah.
and we all get plunged into darkness.
It sounds so plausible, and it's a constant talking point. But this is where we do our deep dive. We've gone through these really detailed technical reports from groups like Modacy and Italy's energy regulator, AREA, and, well, what they show is profoundly counterintuitive.
Exactly. The technical consensus is that EVs, they aren't the threat to the grid. In fact, they are the essential strategic asset we need to actually make the national grid more resilient, more stable, and, capable of handling huge amounts of renewables.
And this isn't about ignoring the risk. It's about understanding that the tech to manage it is already here. We're going to show that the EV transition isn't about if the grid can handle the power, but critically, it's about when and how that power gets delivered. Prepare for a total flip in how you see this.
So let's start by just destroying the volume myth. When people picture millions of cars, they think the total energy demand is going to, what, double, triple?
Right, it feels like you're just bolting on this massive new layer of consumption. So by 2030, with a pretty big transition happening, how much energy are we really talking about?
The Modacy projections for Italy are really clear on this. By 2030, even if the fleet grows to 6.3 million electric cars, plus almost a million commercial vehicles and buses, their total annual electricity use would be around 15.5 terawatt hours.
15.5 TWH. That number, I mean, it sounds huge on its own.
It does, but you need context. Italy's total national demand right now is about 366 TWH. So this massive, projected EV fleet is just 4.2% of the country's total annual demand.
Only 4.2%.
Yeah, the sheer volume of energy needed is it's completely manageable for modern grid. It's not doubling consumption. It's not even close.
Okay, so that is the first crucial distinction. The total amount of water in the reservoir is fine. But if it's not the overall volume of energy that's the threat, what is the real engineering challenge?
The challenge is instantaneous flow. It's the pressure on the pipes measured in gigawatts. Think of the grid not as a reservoir, which is terawatt hours, but as a set of pipes, which is gigawatts.
Ah, okay.
Italy's system capacity is about 60 gigabillion. If every single EV owner rushes home and flicks the charging switch at 6:00 p.m., that sudden simultaneous power spike, that's the threat. That's what hurts the local networks.
So if everyone tried to charge at once, the system would fail.
It would. I mean, the report showed the grid couldn't handle all 41 million vehicles charging at the same time. But, and this is the key part, they also showed that the current capacity could comfortably support 5.5 million EVs charging at the same time at a standard 11 kilowatt rate.
So we have the pipe size.
We have the pipe size. We just have to manage the flow through it.
And this brings us to probably the most important acronym we need to get our heads around: Vehicle Grid Integration, VGI. This is the technology that manages that flow.
VGI is the whole suite of tech that lets the grid talk to the car. It transforms the EV from this passive consumer into an intelligent, responsive, smart asset. And that's where the magic really happens.
By enabling communication.
By enabling communication, we can shift that high-risk 6.000 p.m. charging peak to, say, 1.00 a.m. when demand is super low.
And in doing that, the EV fleet stops being a drain and it starts becoming a massive sponge for clean energy.
Precisely. We always talk about the problem with solar and wind, when the sun isn't shining.
Yeah.
But we also have moments of overgeneration where we make more power than the grid can use, and that clean energy has to be just wasted, curtailed.
Right.
VGI lets the entire EV fleet soak up that wasted excess power. And the studies suggest that just by shifting demand, we can cut that overgeneration from renewables in half.
That's incredible. You're turning what everyone sees as a liability into this gigantic distributed storage solution that saves clean energy from being thrown away.
And the key to doing this, like right now, isn't some complex, futuristic gear. It's something we call smart charging, or V2G.
The media always jumps to the speed, the fast chargers, the battery size. Why are the experts so focused on the smarts?
Because V2G is simple, it's achievable, and it is effective right now. It's strictly a one-way controlled charge grid to vehicle. It doesn't need to send power back. The smart part is that it can modulate.
What do you mean by modulate?
It can vary the charging intensity, or pause the session completely, or just shift the whole charging window away from that evening risk period. It's load management, but without all the complex bidirectional hardware.
And the sources we looked at highlight that Italy is actually way ahead in Europe in making this a reality. Why should we care about this local regulation globally?
Because Italy has basically created the template for doing this right. They have two huge strategic advantages. The first is a nearly complete nationwide rollout of second-generation smart meters.
So the communication network is already in place?
Exactly. These meters have a secure, standard data channel, they call it Chain 2, that provides the backbone. The utility can talk to the charger securely. You don't have to retrofit the whole country.
And the second point deals with the chaos of having, a dozen different charger manufacturers that don't talk to each other properly.
And that's where standardization is key. Italy's national standard, CEI 021, it mandates a specific gateway device. They call it the Controllore di Infrastruttura di Ricarica, or CIR.
Okay, that's a mouthful.
It is, but you don't need the name. Just remember what it does. It's a standardized, mandatory communications brain for every low-power home charger.
Ah, so it's a universal translator. Doesn't matter who makes your wall box, the grid knows exactly how to speak to it through the CIR.
Yes, and this immediately avoids the messy, fragmented systems you see elsewhere. It creates a truly competitive, interoperable smart charging market right from day one. And it even lets regular homes participate in these flexibility markets. That standardization is the blueprint.
So V1G is the immediate play, and it relies on a statistic that, well, when you first hear it, it just completely reframes how you think about an EV.
We call it the 20-hour rule. It is the single most powerful factor in this whole conversation.
Yeah.
On average, a personal car is parked, idle, doing nothing, for 20 out of 24 hours a day.
20 hours. We spend maybe 4 hours or less actually driving them.
Think about that. It means the EV is not primarily a mode of transport. It's primarily a massive, mobile, idle battery. All that downtime is a huge distributed energy resource that VGI Tech is designed to tap into.
So instead of worrying about that one peak hour in the evening, we should be focused on where these cars sit idle and for how long.
And leverage those long windows. Overnight charging at home is the obvious one, but daytime charging at the workplace is also incredibly valuable.
Why there specifically?
Because that's when midday solar power is at its peak. Charging your car at the office soaks up the cleanest, cheapest energy available, which minimizes the need to fire up expensive, often dirty power plants later in the day.
This brings us to the part where the value really just explodes. Bidirectional charging, V2G, where the car starts sending power back to the grid.
V2G is the transformative future. Your car can actively push stored energy back into the grid to help out, or it can power your home. That's V2H during a blackout, or just when electricity prices are really high. The value is immense.
How immense are we talking? What did the Modus E and CESI studies project?
The figures are, they're staggering. By 2030, the EV fleet, used intelligently, is projected to cut renewable energy waste, that curtailment we talked about, by 45 to 50%. And for grid stability, the EV fleet could supply up to 15% of the entire network's reserve needs.
Wait, 15% of the reserve needs? That's usually covered by these expensive, fast-acting natural gas plants. That sounds like a huge economic shift. The reports even projected a potential drop in dispatching costs of up to 40%.
Which translates to an estimated annual saving of around 800 million euros.
That's the potential economic win. Let me push back on that, though, because 800 million euros a year sounds like a massive, ambitious number. What are the biggest risks or assumptions baked into getting a number like that?
Well, that savings figure is absolutely contingent on successfully deploying a V2G system that is highly used and fully interoperable. The savings come from replacing those expensive reserve services and selling that stored clean energy that would otherwise be wasted. But you're right to question it. It needs smooth, regulatory, and technical pathways, which, as Aria points out, are currently full of hurdles.
So V2G is the promise, but it's not quite ready for every driveway just yet. What are the main things holding it back right now?
We see three major interlocking barriers. First is just hardware and software maturity. We just don't have enough V2G-equipped cars or affordable, compatible chargers on the market. And crucially, the international technical standard, it's called ISO 1511820, which defines how the car and charger talk to each other securely. It's still being finalized.
So you could buy a car that says it can do V2G, but you can't buy a charger that speaks the same language yet.
Pretty much. The second barrier is cost. Bidirectional chargers are complex. Right now, they cost 4 to 6 times more than the standard smart V1G chargers we just talked about. That huge upfront cost for a consumer is a massive deterrent.
And the third hurdle is just whether anyone can actually make money doing this, right?
Yeah, unproven business models. The financial models have to make sense for everyone, the utility, the car owner, the service providers. And we have referenced this pilot in Switzerland, V2X Suisse. It worked technically, but they ended up dismantling the infrastructure because the ongoing maintenance costs were just uneconomical. Until those numbers work, widespread V2G is probably unlikely before 2030.
That is a necessary reality check. But for the person who owns the EV, there is one fear that outweighs everything else: battery health. If V2G means I'm constantly cycling my most expensive component, am I just killing my battery for the good of the grid?
And that is the single biggest consumer barrier. But the scientific finding that ERA highlights is the ultimate counter-narrative. It states, and I'm quoting here, that adopting V2X applications does not significantly increase battery degradation and can even reduce capacity loss compared to the conventional uncontrolled charging strategy if properly configured.
Han, that sounds like unbelievable marketing. How can running the battery harder charging and discharging possibly make it last longer than just plugging it in once a night? You have to explain the
Yeah.
science on that.
It's totally counterintuitive, I know, but it comes down to intelligent management. An uncontrolled or a dumb charge is actually really harsh. It just blasts power in until it hits 100%, stressing the chemistry, and it often lets the battery sit at temperature extremes.
Okay.
An intelligently managed V2G system doesn't run the battery harder. It runs it smarter. It operates strictly within optimal parameters. It uses algorithms that avoid the charge extremes, like it'll keep the battery between, say, 30% and 90%. It also carefully manages the charge and discharge rates to control the internal temperature.
So it's about avoiding those stressful conditions.
Exactly. By avoiding those extremes and managing the thermal state, a properly configured V2G system can actually be less taxing on the battery than just plugging it into a dumb charger every night.
So the intelligence of the system is actually protecting the battery. It's not just for the utility. That completely flips the calculation for the consumer.
It does. It moves the whole conversation from one of sacrifice to one of optimization.
Okay, so if V1G is the standard for right now and V2G is the 800 million euro future, what's the strategic roadmap? What should policymakers in the industry be doing?
Based on the RI recommendations, there are really three strategic imperatives.
What's the immediate action item?
First, accelerate intelligent private charging. This means policymakers have to mandate V1G readiness, that mandatory societal standard compliance in all future incentive schemes. Every new charger that gets installed has to be grid ready from the start. No exceptions.
And the second one deals with that complexity we talked about, getting the cars, the chargers, the utilities all on the same page.
That's foster system-wide collaboration. You need the car manufacturers, grid managers, regulators, and energy companies all working together to hammer out the remaining interoperability challenges. If they can't talk to each other seamlessly, the V2G value just collapses.
And finally, keep the research going while the market catches up.
Absolutely. Sustained research and experimentation.
Mm.
Because V2G is still maturing, we need continued funding for R&D, especially focusing on real-world data on battery life cycles and constantly refining those charging algorithms. The path is clear. Secure the grid with V1G now and unlock that massive value with V2G later.
We started this with the terrifying idea of the grid collapsing, and we've ended up realizing that the electric vehicle isn't a passive drain, it's not a burden, it's an active, vital, and intelligent partner in maximizing our renewable energy.
The narrative shift is complete. The next time you plug in your car, you're not just topping up your fuel tank. You are participating in managing the national energy balance. You're using clean power that would have been wasted, and you're acting as a necessary piece of our future infrastructure.
And that really is the most important takeaway from this deep dive. If smart charging technology can actually extend the life of the most expensive component in your car, the battery, compared to a basic dumb plug-in, what other parts of your daily life could be optimized and prolonged by adopting intelligent management? Think about the appliances you use every day. Which of them are actually secret, untapped grid resources just waiting to be intelligently managed? We'll catch you next time you dive deep.